And I'll broadcast to your guys' screen too, which I'll probably have to turn on and off as people filter in if they're coming in late. So I'll go to your screen here now until somebody needs to log in. All right. Yeah, so what I've got pulled up, if I go to to my Canvas course here. I know we talked through all the resources that are in here. I don't need to talk through that again, but yeah, I'm going to open up this worksheet and just start filling it out. And we'll notice that if you open it up, it should already, I'm pretty sure it already has the first one filled out. So um, jump off there. Jump off your screen again here. But yeah, you should already have the first one. So if I open up that worksheet, it looks like this, kind of the original instruction sheet out of our these definitely come out of our chapter 11 of our textbook. Well, maybe 13-1. I think this is information that's I think these assignments have come out of our theory textbook. I don't know. But it all is found in chapter 11, so I'm not sure why maybe it's just problem 13. I don't know. I could be wrong. And either way, we're going to try to replicate this drawing here, and I'm not too concerned about the sheets of paper we use. Whatever, it's kind of a drafter choice. I think mine are on my example that I show is on a B-size sheet though. And what they've given us is the thread notes for these fasteners essentially. So we're going to work off these thread notes is what we have to work from here. So A is a flathead cap screw. That's this one. Flathead machine screw might be a common term. It's a 3/8/16 UNC. So now that we've done a little thread note work, we recognize this is a unified national course, standard thread, 3/8 major diameter, 16 threads per inch, right? That's how we read that. 2A, uh, just a normal fitting thread to external internal thread, and then an external thread for the A. So that sounds like how we know how, and it's 2 inches long. So this is by 2 inches LG long. So they've drawn this thing 2 inches pretty much from the head down. It's 2 inches. That's actually how these are measured. They're actually because they are considered to be applied below the surface, then the actual entire machine screw length is usually from very top of head to the overall length. That's not the case with all fasteners, and not the rest of them, in fact. Just that one. So we'll start drawing that one first. What we do is and then we're going to draw what? That's just the flat head. Then we have a round head cap screw, definitely made to kind of be a finished look. I'm trying to think of where you'd see this stuff. I don't know. On a round. What's that? Fastener Group 1 worksheet is what I have open. It's a Word document. Yeah. Heck yeah. Yeah. And then we kind of have what is this one? And so that's a round head. Oh, a 1/2 inch 13 UNC 2A, 2 1/4 inch long. Is this one? Okay. 2 1/4 inch would be from the underside of the head down to the end here. And then this Philister head cap screw, this one right here. Definitely still a nice finished look screw. I feel like these three right here really have a purpose as kind of a finished head look. I mean, they do protrude past the surface, but there's a lot of machine parts we put together that we like this finish head, and some of them are an older style for sure. I feel like the round head ones, they have their application. I think it's almost kind of a decorative head in a way, but anyway, this one is, and I feel like this one is the combination between a round head and kind of a shoulder or a socket head cap screw. So um, anyway. What is this one? So they call it a Philister head cap screw. Philister head cap screw. 5/8 11. That's kind of a big 5/8 major diameter. Is pretty big screw size. 5/8 11 UNC 2A, 2.5 inches long. And then we have an oval head cap screw. Definitely another nice finish over. It's like what the child of between this one and this one essentially, and definitely meant to be kind of a yeah finished ornamental kind of look. I don't know. I wish I had examples of what they might fit in. And then what? And then we just have a regular cap screw, hex cap screw, they might call it, or just a bolt. Yep. Got it with a nut, I guess. Yep, with a nut. And it's a big hex cap screw too, a 1/8, a 1 inch major diameter, 8 threads per inch. So 2.5 inches long. Then we have the socket head cap screw one. It's a hex head, 1/2 inch 20. First one that's a fine thread. Then we have the cotter pin. Okay. 3/8 diameter cotter pin, 3.5 inches long. Okay, good. So we have the information we need. We have the thread notes. This is kind of how these are what would end up in a likely the way these are thread noted would end up in a table, could potentially end up in a table if you had and so I think when I finished my drawing, I ended up putting all of their descriptions in a table and kind of and then I just did used a local note similar to how they did to designate which one's which, and then I had a table next to it, and I applied these thread notes to my table. That's that's one way to have done this drawing. The other way I could have done is just to take a multi-leader line on all of these and point to them and add the thread notes. So you'll see both ways done. And yeah, maybe the table being my preferred method. Yeah. So what we would do here is we go down here and we've just got the information we need to fill out to be able to draw this thing. And so A, B, C, D, E, F. How many we got? G to do? Yeah. So that's all of them. Each one of them has their own column here. With the first column for A already being filled out. So this is the flathead cap screw. I call it a flathead machine screw, but so I've already populated. So here's the thread note that they gave us in our assignment. That's how long it was. It's the type of fastener. So we just needed to find all this information. So I think when I uploaded this, I already filled out the first one for you. So I went through Appendix B and I found the major diameter, the pitch, which is essentially just 1 divided by 16, because that's how we find our pitch, because this is given in threads per inch right here. We've learned that this week, I hope. That's how I got the 0.625. And then we have a minor diameter, which really I found using a little formula that was out of Appendix B. So I figured that out. Then I had to figure out the head height. And let's see, where I would have found that out would have been Appendix B, I'm pretty sure. So I'll review that real quick. I think I have my Appendix B open. And so I would have looked for the standard, which could potentially be right here. I know this is a hex cap, and ours is a slotted, a slot type, like this type of fastener head, right? So maybe I would look at this one for that head height, this H. And so if I look at that, their chart here, I think the difference if you would have used this first one here versus the next one down, maybe they're the same. I could cross compare them. The only reason why they might be a little different is because when you put this different bit head in here, maybe they need a little bit thicker head to do that than the slotted type bit needs, and the head height. So I think that would probably be the difference that's driving that, if there is a difference, just the type of driver that you would use to take it in and put it out. Or wait, put it in and take it out. There we go. That sounds better. So ours is, let me see. I'm just double checking myself. I know I filled this out and I just can't remember. I just want to make sure that it's right before I take off with it. But the head height there, let's see here. Mine's a 3/8, so I just need to do the little formula thing real quick check here. So mine 1/4 inch through 3/8. I'm going to use this row here, and I'm going to say it's just 2 times the diameter, 2 times the major diameter for that. So that should be 2 times 3/8. Let me double check that, because what do I have here? Oh, let me check. Am I looking at that right? Let me go back. That's why I'm doing this. HH. Oh, that's going to be for my head diameter. Sorry, I'm going to need that too. But just for the height, I guess I'm looking at first. It's actually 0.56, 0.596 times the diameter. That's what it is. So I don't have that off so I'll hold my calculator here. And it is a 3/8 fastener. It's 0.375. And a 3/8 fastener is big fastener still too, actually. for the major diameter, but I'm going to multiply that by this little constant here, 0.596, 2235. So I'm pretty sure that's how I populated on this one, 2235 right here. I think what I'm showing here is that I think if you use that other, if you weren't paying attention, that other, flathead machine screw is the one you used, I think you'd end up with just slightly different. So I don't feel like it's going to matter either one you use, but I think that's why I have one in parentheses here, is using which page of that appendix. They're ever so different. And this makes sense to me. The other one's probably just a little bit thicker head for that bit, is my guess. Head side height doesn't apply to this one, so the head diameter does, and that's 2 times the from that same chart. I can remember it's 2 times 3/8, right? So if you don't know that's 3/4, then you do 3/8, 0.375 times 2. So I'm going to use the head diameter as 0.75, but I think I have another one in parentheses because there's probably another chart in there that if you're using it, you might get a slightly different, a little bit more than slightly different here. There's definitely a bigger difference than what was going on here, but um, I guess either one would work though. And I'm not sure what chart I'm looking at to get that one, but I think I'm just prepared if anybody fills this, if it would have filled this out, there may be a few of these fasteners where you get, depending on which sheet you're referring to, you might get a slightly different dimension than me. And then it has a countersink angle from 80 to 82. Of course, we wouldn't know that unless we were looking through that. That was given to you, but it's really right here. 80 to 82 was given to me here. And I think that's the same, maybe on the upper one, 80, 82 plus or minus 2. Yeah, so that one could be 80 to 84. I might just draw mine in at 80. Something simple and easy since it's within that tolerance. And let me see what the last information I got. So that's it gave me this in it gave me this in the length of threaded section, or the length of the bolt is 1 inch, or the whole length is 2. I guess, the length of threaded section is 1 inch. I think that was an old, I think, okay, so what's going on here, and I say fully threaded, is I ended up looking these up on a modern, like McMaster car, and I'll show you this in just a minute but what I want to say is what I noticed if I scroll up here, they're kind of leading you on as if these are not fully threaded. I mean, these are simplified drawn threads for sure. Major and minor diameter, the only thing that are really showing. But why they have this separation is because they're saying, well, it's not threaded from here down, or sorry, from here up. It's not threaded, and it's threaded from here down on all of these. Well, I kind of question that. And the original way they did draw this, I saw previous instructors, they would put these in there. And but I just went to McMaster Car and I looked up this flathead cap screw just to see are they fully threaded or not. And really, you actually there was no option to buy this one that was partially threaded. So I've drawn mine fully threaded. In fact, I went back and looked up all of these, and I'll show you how I did that later today. Maybe we'll look one up or look these up after maybe we draw them. But that was my question, was whether I just kind of questioned when I saw them, like, are these really partially threaded? And so I just went and double checked myself from a website, and I couldn't find any that were partially threaded. So the way I drew mine on the assignment, if you're looking at I'll go in here real quick. Well, that's the worksheet. So you're not going to see much there, but let me go to the actual drawing assignment where you see what we're headed. The way where we're headed here is this, what's shown here. So mine are fully threaded, all of them. And that's just me doing a little cross-reference work to the actual what you can purchase the nowadays, and they're all fully threaded at these lengths. Usually what drives partially and fully threaded difference is the length of it, right? The longer it gets, generally it starts to we start to have sections of our fastener that's not threaded. So for these particular lengths, I couldn't find any that were partially threaded, so I drew all mine fully threaded. So I think that's what I'm showing here on this worksheet that might be a little confusing. I think the original assignment, they drew them 1 inch of threads, and I couldn't find that, so I drew mine fully threaded. And then this slot width are the last couple things I need to know. There's a slot width and a slot depth, and that's just because that's the type of fastener head or the bit that it would need to put it in or take it out. So I think let me look at where this is captured. I'm gonna go to my appendix again. I can't remember if they gave that here or not. I don't think so. I think they never really dimensioned the slots here. But I do think I found a reference that did. So if I scroll down, yeah, because I don't think any of the original Appendix B stuff had good information for the type, when you're drawing the actual bit pocket for the tool. I just don't think they had them. And so I think towards the end, after Appendix C, and we get these add-on references that I have here. I know I'm going to need this one for the Philister cap because I think that's why, specifically, that's why that one's there. But I was just going to look this, and they show the slot widths on that one. But let me just see if they show, if I have one. Here's going to be these oval head machine screws. Okay. I'm just looking for the one that's a flat head machine screw if I have it. There's a round head one that captures the slot size. There's one for the socket head type. Okay. And maybe I don't have it, and maybe I don't know where I got that information. I don't see it right offhand. Let me just see. Yeah, I was pretty sure these are all metric ones. I was pretty sure they never dimensioned that. So now I'm wondering, how did I come up with some dimensions and which reference sheet did I use? I don't know. I'll look for it while we're going here. Which one here? These ones match which one? From this one here. It's the what? Oh, it is on there. These ones here. Right here. If I was looking at this one for the, yeah, that's interesting. Okay. And I don't know if they would match this one or not, but yeah, oh yeah, so you're saying if I zoom, I'll zoom in on my chart a little bit here, and and maybe I'll blast over to your guys' screens for a minute. So I'll show you what I'm looking at. Let's do it. But yeah, let's compare that. Yeah, let's see if that's right. Because I may have just, I don't know, I may have pulled it from somewhere. I think I would have, I don't know. But it's 3/8 diameter, right? And so we're looking for that T and J size there. T, clear over here, and J. So you're saying I did match this 1.24. So let's see what I've got on my little split screen here. Maybe I will. No, I will spill my coffee. How about that? I get a little aggressive here. I do want to. I'll start my recording again. Start my share. Yeah, I think so. And so I think what I'm gonna do is I'll just move on with it. I can't remember, like maybe it'll show up to me like when I'm digging around a little bit on one of the other fasteners or something. But I kind of forgot that I already populated this one for you guys anyway. So yeah, I will do a little research. I definitely, obviously I found something it's like a range, and that's kind of how these show too. These are definitely shown in a range. I'm just not sure which chart I pulled that from. It's yeah, like you say, it's very similar. Here's like which one's my three. Let me zoom in just a little bit less. I can see my side. Let's see. Yeah, 3/8 is this bottom one here, huh? And the slot depth, I say zero point 0.3 to 0.068. Yeah, not quite as deep as this, which makes sense. This is definitely a deeper head. You can potentially hold a bit there. And then the slot width 9.4 to 8.1. Yeah, you're right. It does definitely, my width is the same, but the depth is a little bit off. So there's got to be a chart somewhere that I'm just not seeing right offhand, but I'm kind of just wanting to just quickly vet those these dimensions, and then I'm gonna start drawing this one now, and then we'll come back and we'll fill this one out and we'll fill this one out. But I think I'll fill one out, draw it, fill one out, and draw it. I think is the way I'll do this. That kind of breaks up the monotony of going through charts and looking for dimensions. It's good, but I like to break it up with a little drawing. And we'll look for this as I continue to go. I'll look for where I got this because it seems like I'm definitely looking at a chart that must exist somewhere. I thought I condensed them all into Appendix B, but maybe there's still a rogue one floating around. So with that, I'm going to keep my Appendix B up. I'll keep my worksheet over on my other screen, and then I'll jump into not Copilot. I don't really need Copilot on right now. Let's see. Yeah, I'll jump in and start drawing this. I think what I did, I'll just lay out a little bit of construction line work here. I ended up, setting kind of a surface where my heads were all kind of aligned to, and so yeah, I could pick anywhere in here, and I'm just looking for a surface line, like a horizontal line. I think I did follow. If I look at my initial layout, maybe I'll just draw some center lines on these layouts, or just some construction lines. I think I did space these out of this. It didn't have to be for sure, but I do think there's enough room, and it'll fit about like what it looks like here. If I just go inch and a half, inch and a half, inch and a half, and then a 3/4 and a 3/4 inch spacing to get these one, two, three, four, five, at least these six spacers or fasteners spaced out. I just drew this line here as the surface for the heads to kind of something. This one kind of bugs me because I feel like it should look like a counter bore. I should, but it's okay. I feel like that one should almost be one that sinks in. But the fact is about these, we don't always counterbore the surface for this. Sometimes they do. Sometimes they do sit on the surface like into these ones. So it's not totally wrong to see that they would put, a socket head cap screw on the surface like this. That's actually doesn't always have to be counterbored. So it doesn't bug me that much, I guess. So I got that surface in. I'll lay out those alignments there. Oh, maybe just anywhere. Um, I might start one here at the start of my line. You can do this any way you want though, and then I might just offset this line. Like point, I don't know how long that is. It's just some random length. It might not be long enough for what I need. I can change it as I get there, but I'm gonna offset it. Maybe I'll do one quick little check. I will check that I drew it long enough because I think 2 or 2.5 is how long some of ours are. So I'm 13 inches long. Yeah, plenty long. I can trim that later. I'll leave it then. So I'm going to offset that thing an inch and a half. I think that's the offset that maybe that didn't take my num lock's not on. There we go, 1.5. I thought my keyboard has failed on me already. Nope, it's still working. Inch and a half there. Yeah. Was there three of those? One, two, three. These are going to be, I'm not going to draw on this one probably. In fact, I'm going to start my first one there, second one there, third one there. Let's see my two, three, and then I need 2 3/4, 1 3/4. So I'm gonna do another offset. All I'm looking for is the center lines of where I'm gonna build my fasteners here. That'll be 1 2 3 4 5 fasteners. 1 2 3 4 5 6. Oh, did I maybe miss up one here? Inch and a half, and then an inch and a half. And then I shouldn't have done this one yet. Sorry, I needed one more inch and a half because I deleted my first one. There we go. Anyway, I've just got myself a grid to work from. So I'm going to build this first one right here on this first center line that I've drawn. I don't know what the spacing was I used between the two views. Oh, it's 2 1/4. It shows that. It's got that on that little sheet. So I'm going to offset this line 2 1/4, this one. And that's kind of the center line of the heads above me. The other thing to note, and I think they did this to try to fool you, and it would have fooled me if I didn't know. But they drew theirs the opposite way, and they really, I think the standard for these is that they come this way, especially when they're slotted ones. And since we have four of them that are these slot type bits, they technically are supposed to be spun the other way, kind of like down and to the left, I guess, instead of down and to the right. I mean, the amount of times you're gonna have to draw faster is probably gonna be pretty limited anyway, but that's a small detail of note. Maybe they kind of visually showed it incorrect and wondered if you would correct this the other way, but I don't know that we'd be familiar enough in our careers right now to say, oh, I caught that. I don't think so. But if you look through your book, they're mostly always that down and to the left. orientation for the slot in the top view. So I'm going to start with my top view though. I think I'm going to put that in and the slot width. Yes, I am. So I think I'll come up here with some visible work, draw the top view of that fastener. Right here is where mine's going to start. And I have the overall diameter of the head at, I'm going to do the 3/4 of an inch one. That's a 3/8 radius for me. That's actually the diameter of the head, 3/4 of an inch. Yeah. And then I could put the slot width in here. It's kind of at a 45-degree angle, so I could snap a line across here that's 45 degrees. Maybe if I select that I gotta change my snaps here to 45 degree. I think I'll put in the construction line here. Then I might be able to copy this over anyway, but this is what I'm looking to do is have a 45-degree right here, right, coming through as just a construction line here. I'll just extend that through. I might just copy that over and plan ahead for the other ones just while I'm in this moment here. Um, one, two, the first four fasteners will need that across there. So maybe I'll just, I might, yeah, 45. This is a 45. Yeah. Depending on where you're referencing, but from up here, it's 45 for sure. Yep. Down and through. And that's what it's going to be the center line to base, kind of the slot width off of there. Because I can draw that in before, and then I'm going to project some stuff down. Yeah. But I think I'm going to copy this thing. I'm going to need one of these for these first four fasteners. They're all these slot head type. So I'm just going to get ready with those. That way, when I get their diameters, okay, just a little. And then I'm going to do my own depth, my own slot width here. So I will use the mysterious wherever I got that information for the slot width. I could pick any, it's a range there. So I'll just pick either the low or high on the range is what I'll do. It could potentially be a width that has a tolerance with it if we were fully dimensioned something like this, if we were actually dimensioning the fastener, which you can see we're not, we're just drawing them. Then we're just going to do a table of thread notes. So we're not really going to detail this out. But if you were drawing something like this where it's given in a range like our slot width is, I might pick when you're dealing with tolerances, which we will maybe in group two. There's first time we start to tolerance stuff, but you just what do I say here? You're going to pick maybe the center of the range to draw, and then you're going to plus or minus from there, or you might pick one side of the range to draw. That's kind of confusing, but I'm just going to pick because I'm looking at these two numbers that I have. I mean, this is the range for the slot width. I'll just pick the wider one. That's fine. So it's going to be 0.094 when I'm finished with mine. Because at this point, yeah, I wouldn't know what's right or wrong. Should I go for the median of the range or the low or the high of the range? Well, it might matter in some cases if when you're really tolerancing your stuff, but we don't have to tolerance this, so I can just pick one side or the other. But you might not know what half of that is. What I want to do is just offset my 45-degree line is the way I'm looking at this. So I'm going to say, well, it's half of 0.094 is the widest. I'll divide that by 2. I'm going to offset mine by 0.047. All I'm doing is saying this, 0.047. I'm going to offset this. That's actually my slot width, right? So I can trace over that. I think this gets a little bit of an additional modification to it once we put in the minor diameter or the major and the minor diameter. Um, so I'm just drawing a line over that from its outer circumference. Yeah. If I really look at that, you can see there's something else going on there. And what they're picking up is maybe as this thing, well, we'll look to finish that off. I've just drawn the slot width all the way across the head diameter, and we'll come back to that. So I may have some fine tuning stuff I'm going to draw down here. I'm going to project up, I think is what it is. So I'm going to project down and start doing the front view of that fastener now. Yeah, I think so. Just want to know the I just want to know the diameter here down here. That's the main thing I want to know, I think, to start this fastener down below. That's going to be where the diameter appears as a line for sure. That's going to look like a line. It has and then we're going to orient the slot so that I can look down through the slot. And that's just going to kind of be like, that is that inaccuracy between top and front view that we pointed out that first day. Yep, I'm going to draw it so that I'm actually looking down through the slot. Kind of break the rules of real, true orthographic projection, I guess. And so I'll have that. It's going to be that same width that I'm going to put in here, but maybe that'll be a kind of a fine detail. Let me just get the overall profile here. So now I'm going to, um, well, I don't know what I'm going to do. Let's see. I just want to offset for the diameters as well here. The major and the minor diameter is what I want to draw. Major maybe first. So let's do that. Maybe I'll put in, I'm going to need a center line. I might just put in a center line right here to use as my offset. So I might just draw this down and I'll tuck that in. I mean, eventually the center line is going to go through here and stick through here our normal 1/4 inch extension here. So I'm going to set this up. I'm going to use it for my offset. I could have offset the big construction line I have. It's just a huge line. I don't want to have to trim it all up. So I'm going to set myself a little smaller line. So I'm looking for the major diameter. That's going to be the 0.375 or 3/8 fastener. So I just need half of that though, right? So half of 3/8 is 3/16, 0.1875. Might not know that, but I do. We could have done the math on it though on our calculator. All I'm doing is offset this. This right here. I didn't dial that in yet, but yeah, it is. So I'm at least a couple inches. I think when I pulled my line, I saw that it was like 2.5 plus inches. So the fastener itself is only 2 inches long, right? 2 inches. Yeah. 0.1875 is what I just offset those, and then I'm changing those to visible lines here. Yeah, that's what we just drew. That's the major diameter of the fastener, right? 0.375. Yep. Right here, 3/4. So this was a 3/4 inch diameter, which I projected down to draw that line actually. Yep. 3/4. This isn't quite how this looks. This has got a V shape to it here. I'm gonna do one more offset though, just because I want to know the minor diameter. So in your book, there's good, and it'll be on your quizzes. I have previewed the quiz for this week, and knowing the difference between schematic, simplified, and detailed views of threads is something that shows up. So I should be able to recognize that this is a simplified view, and simplified just have visible lines for their major diameters and hidden lines for the minor diameters. It's kind of those roots of those thread, which is why we have that on our chart, right? So we have that minor diameter. So I think I'm going to offset now for the minor diameter. 0.3073 is that whole minor diameter. I'm going to divide that by 3. That one I can't do in my head as well. Maybe I could, but I'll use my calculator here. So what do we got? 0.3073 from my chart divided by 2. This is my offset for the minor diameter. 15365. I'm probably going to put in all those numbers. Kind of a big, I'll move this over so I can see what it is, but and this is why it's nice sometimes to use this calculator when you're doing that because it stays up on your screen while you're punching your numbers. So remember your calculators there. I could have done that here too. 0.3073 minor diameter divided by 2. I like this. So I'm going to offset my center line again, maybe by 0.15365. Sounds good. And that one, I'm going to push these to a hidden layer. And that's just because that's the way our standard is yeah, for simplified threads. Sorry, my trim, where you at? Right there, good. And then I can worry about the head we can terminate it here. I just need to lock in how long that is. And so it's only 2 inches long, and that's going to be from top surface down the full the full thing. So 2 inches down. So I might just go to my visible layer and I might cursor down that 2 inches. So I'm going to target here, pull down. That's two. That's actually where my lines will terminate here. I'm going to pull this across. Okay, so that's where it terminates. The only thing is we don't just terminate it square. We actually just we cut this back from major to minor. Um, if I if we can tell that detail from our sheet or from my drawing for sure, but you can see that what they're doing is it might look like they're going beyond the major and minor. Let me see what I've done on mine. Well, I think it's just the standard is kind of the yeah, you'll see in your book that I think the standard is just to cut the kind of almost look like you're putting a chamfer on this, but we would consider that just between the major and the minor. I think I'm looking through your book a little bit, but it's pretty common for that to be a 45-degree little chamfer there. So if I do 45, it might just cut it off like not necessarily. So I guess what I'm thinking is maybe it's not I don't know. I guess I could go from here 45 and chop that. Let me see what I did on mine and see if I did. It looks like I came from here. And so how long is this? That's a good. I think it's one pitch or something. Let me measure mine. It might be it's either one or two pitches. It's one pitch. So I go up one pitch and then I'm going to 45 that down. That sounds right. And then these are 45s. I think if I were to look up some of those into some of the little drawing schematics, I have a few other PDFs that you can reference for this, but so what I do is I come up one pitch and that's why we have that on our I'll pull this up here and see what I think a pitch is something that we identified. Yep, there's one pitch kind of from thread to thread or peak of thread to peak of thread or the root of thread to root of thread, but yeah, 0.0625. How I got that was that 1 divided by 16. That's what 0.0625. So I'm going to come back to my drawing here and at least offset this one here, piece this together. I'm going to offset that one pitch right here. So I'll say offset. Seems like I'm using offset a lot. 0.0625. That's one pitch. And then I'm going to draw that like that. And then I think I just came 45 down from here. And I think you'll see some of your maybe they have some fasteners they show them with a 38-degree. I think I did all mine at 45s here. So all I did was come down here with a line. And I'm still targeting 45s here, so that's good. And I should be able to click here, look for that 45 is going to be the first one that shows up as I project like that. Yes, that's good. I think that's how I ended up terminating mine. Is there so yeah, as you read your book or if you've come across any writing that tells me anything different there, let me know. But I think that and I'm going to trim out the rest of the stuff. So all this other stuff I don't need and I don't need this. So I kind of terminate my just drawing across that.
And you said that the whole basket was 2.
2 inches. Yep. From head. Yep. From head down is 2 inches. That was given in the problem. Yeah. Yep. It was given. Yeah, I had it there, but I only had it there because in their thread note, they also included all the lengths in their thread note, which on a table you might have the thread note in one column, and then you might have the length in another column on a table. That way, you could almost carry one thread note in a table and have maybe a couple multiple lengths if your part had multiple, just different length but the same fastener. Pitch is always one thread, one peak to peak. Yeah, not always the same. It's always dependent on, yeah, your pitch is always dependent on whether it's a coarse or fine thread. Yes, it's going to be different for every. It's going to be different for every one that we do here for sure. Nope, no standard. It's no standard pitch. Nope. Yeah. And when we actually start filling one out, or when we do the next fastener before we draw it, we'll nerd out over that a little bit. So now what I need to do is go put in the countersink head And so I think the way I'm going to terminate that is I'm going to come up here. What you need to know is that that included angle that we I think we said 80 to 82, or it could technically be 80 to 84. I'm just going to do mine as an 80-degree included angle. So these can be kind of tricky. Sometimes I guess these wrong and then I just fix them by so sometimes I draw it wrong to draw it right. But essentially what I'm trying to do is, oh, if I thought that the included angle is going to be this way from this, I'll just draw like it's some random line here. This is at 45, so I'll just snap this. It's going to be wrong. I'm going to snap it over to the center. I'm going to do that over here again too. These are just because I have 45 snaps, so I'm just going to draw this line. But what we're looking for, right, in order to draw this correctly, is we're looking for the included angle. That means from here to be 80 to 84 essentially, but I'm going to target 80 because it's just kind of an easier one to target. And really when I drew these at 45, I actually got 90. So it's kind of like I need to go like, oh, I don't know, 5 degrees less or more, if you can think about this, right? To end up hitting 80. So really what I need to be is a little more acute of an angle and not, not this. This is a 9. This would be great if it was, what would we say? If it was a metric fastener, it would be right on the money and they're easier to draw, obviously. But these ones are not. So this kind of goes back to that one drawing we did, chapter 4, a long time ago. So I'm just 5 degrees off. So I feel like what I'm going to do is maybe come in here, and I feel like I've got to go a little bit steeper like this, right? I don't want to go flatter like this. That would be like a wider angle when it's the included angle. So I hopefully I can see that geometry that if I actually went this way 5 degrees more, it's going to actually go out to 110 or 100 degrees. And I need to make this angle more acute. And so like this. So this was 135. I can see it. I'm going to tab over to this column here and say, what does it need to be? Oh, it actually needs to be 130. And then I'll tab back over to the length here. So I think now I'm going to draw this to where it intersects here. I must not have my intersect snap on. I'm going to look here real quick. I feel like I do, but it's not giving me an intersection point there. So I'm okay with that. I'm just going to draw it long, right? This is how I deal with stuff like this. I'll be like, well, I'll just draw it long. Then I know I've created an intersection point now. I'm gonna draw. I'm gonna just target that point where they cross the center here. Then I'll trim this out. Sorry if I actually select trim. And then when I measure this angle, hopefully it's 80 degrees now. Yeah. So sometimes it's just helpful to get some geometry to work with and see like, well, which way do I need to go from there? Sometimes if you sit and think about it too long, you just can't quite decide where to snap the line. My advice is always just like, well, snap some geometry, measure it. What is it? It's not quite right. Which way does it need to go? You can figure it out kind of with, you can math your way into it. You can just kind of CAD your way into it is what I'm saying now. It's easy to draw and erase and have some reference material. So that's kind of what I did there, right? Like I drew this wrong. Wrong is right. It helped me get the right one, actually.
So how did you decide to choose 80 as your angle instead of
Oh,
like the standard? Go 80 to 82.
yeah, I feel like you could. So I think sometimes I would say if it really mattered, I might target the middle of the range, and then I might have my tolerance be. Yeah, I think I would think of something if like because our assignment isn't forcing us to actually put the dimensions to it. But if it did, I would want to dimension it something like this, right? Like if you drew, like I'm just looking at one of the appendix, I probably would do something like this. Either draw it 90 and say it can be, you know, minus none, but plus two. And so, yeah, if I go up to ours, I could draw it this way too. I could draw it at 82 and say it's plus two, minus two. That's that range from 80 to 84. If I drew it at 80 and I actually had to dimension mine, I'd probably have to say 80 minus none, maybe plus four. Yeah. So it does, for us, it doesn't matter because I'm not having to dimension that. But when you actually do have to dimension something and tolerance it, it does matter kind of where you choose.
I mean, as long as it's within the range.
Yeah, exactly right. And what I did is I chose the easiest, like just a nice even number kind of. That's why I chose 80, just an even number. But yeah, exactly right. You could technically draw it in any of these. You delete everything. No, I don't know. No, I'm just kidding. Don't do that. You try to, I don't know, like your lines, which lines aren't matching up? The angled ones that we're doing? And you're just matching up because I'm starting mine here, right? Oh yeah, it depends. Yeah. Let's see. And then I think I terminate this right here. Thanks, Arya. You could mirror it as well. You could totally mirror it. Oh yeah, if you're gonna draw a line to an angle, definitely tab abort, abort, escape. Just checking mine here. I don't know what I drew mine.
Do you measure the length of the threaded section in the very bottom of the jam?
Of the yeah, I think it is included. Like the yeah, the length of the threaded section here, you mean? Or yeah, this I like do you include it in the length? Yes. So mine is 2 from that from the surface line to this is my 2 inch actually. Yeah.
Thread extends. 1 inch of thread is jam.
Yeah, yeah, I guess. Oh, let's see here.
1 inch 0.0225. There just be 1 inch thread.
For how much is threaded? I threaded mine fully. So mine's showing fully threaded. And my reasoning is because let's see here. This one here, I feel like, yeah, this is what I questioned. And I maybe just before you walk in, I was talking about, oh, this is I actually went to the store. Actually, yeah, I went to my McMaster car online. I was like, are those really partially threaded? And for those lengths, they were actually all fully threaded. So I feel like this is a little misleading. And I chose to draw mine all fully threaded. So did we get it? I just gotta trim this stuff out though. Like that. And then you gotta put the slot in. I'm gonna so I'm gonna come back to this. I'm gonna put in my slot width there now and the slot depth. I use 0.94 on the upper part. I'm gonna use that same side of my range. You gotta know what maybe half of that is to come over. Yeah. So I'm gonna say 0.094 divided by 2. Nope, I gotta clear my numbers here. 47. So mine's 0.47 over here. Yeah, 0.047. Then I need to know the depth of this, which is on my the depth is right here. Maybe I'll just put in since I'm doing the widest slot width, maybe I'll just do the deepest slot depth here. But there's no right or wrong. You could choose either side of the range here, I think. So what we got more problems than we can fix. Let me come up and look. I'll push pause here.
So I probably will have to get it all. That'll be fun. Hi. So this go back. So,
Yeah.
oh.
Maybe just delete your white line.
Maybe come back.
Yeah.
And,
I think, what is it supposed to be measuring?
3/4, 0.75. You can just select it like, oh yeah, like it. One way is just select it and over here it's gonna tell us that your diameter is 3/4. So that's will be good. And then you project it down, right? Those projections line up here. So then just come and measure this. Use your little measurement here, distance. From maybe that point to that point, just to make sure it's projected down, correct? It's not,
Oh, not quite.
there's a little bit of inaccuracy. So
Oh, no.
now I'm gonna go look and see how you projected out. Same way in to see if one.
My
needs to be
toolbar's
true.
gone.
Oh, it looks pretty good.
I don't know how she
So
fixed
do I.
it last time.
Maybe one of them slightly pulled out an angle, so I would delete those projections and redraw them, because what, it might, maybe it shouldn't stay orthographically straight for this little thing.
That.
Okay, here, yeah, just forget that a lot, but that's okay. Just chill with that. Just go make sure, yeah, where it's gonna get perfect. If you can zoom into anything like that, you can zoom in, make sure, yeah, there you go. And then how that, yeah, it should be, and then let me just delete your white line, or redraw it, and I want to just measure that, measure me there, make sure, I mean, it's orthographically, it should not. Yeah, you like those. So now go ahead and draw your visible, go back to your visible line. You draw straight across. Okay, and it might be underneath it, we can bring it to front.
Oh, the other day when you lost your,
We'll send the other one back.
your ribbon, how did you get it back?
What are you saying? One
My whole ribbon's gone. My computer shut down.
You just put ribbon in there, man.
type ribbon in, yeah, and it will. Come back up. Ribbon. Show up.
Huzzah!
Yeah, isn't that horrible?
That was horrifying. I was like, what do you mean it's gone?
Okay. Now, just ran away for a second.
No, I think you're good. I think you're, so you think those are not offset, correct, then, the
Right.
weights, or they should be, like, go, yeah, measure that, it should be 3/8.375, clear over the white one, or, yeah. You can measure half of that, that'd be good, then.
Over here,
It should be one, yeah, you got that right, to correct the other way. Yeah, that's good, those look good. So now what we do, yeah, all we want to do is draw a line. So there is a whiteboard underneath there, yeah, I know you draw it, so don't worry about it, yeah, it's good. Do another line now from there, yeah, and pull it down and over, yeah, let's go. Yeah, I think what we end up putting in here, tab over to this one. And put in 130 is what we're gonna do, and then tab back. You hit enter, it'll be okay. Just go ahead and escape now. I know it didn't quite go far enough, just extend it. And push it to the, yeah, perfect. Now you got a point to point.
Okay.
Yeah. Can I just do a double check? That's it. Yeah. What was it before we did it, or just?
It was 81.
Oh, it still is 81. Oh, that's kind of fun, actually. Yeah,
I
it
mean,
could be that.
technically, that was within the tolerance.
I mean, it is in the.
I wouldn't sweat it, actually. Yeah, maybe just go to your annotate tab real quick. I'm just gonna pull up actually a dimension.
You know what? How are they gonna know?
Yeah,
Because we're not
really
directly
good.
going into it, we're just telling them what it's supposed to look like. They're never gonna know.
You're right.
Unless you have an actual CAD file.
And then go out and measure it, and then be like, oh, it's this, the angle is
So
81.
maybe I'll just like maybe just redo it.
How did this
I'm
happen?
interested to know why. I don't know why. It's like could be the way we extended it, and maybe this time we won't terminate it without yeah, redraw that. And then tab over to 130. And then tab back. And now draw that, and now keep drawing it past, like that, and just go so across it like that, yeah, okay, there. Now pull the other one over, or like, yeah. There. Oh, it does say.
It's 131.
We must have something going on here. Well, that might actually not be. Yeah, check this. Might be referencing. Kind of
I don't know if something gets off.
I didn't see it. I don't see it. Especially when you're like, what? Wonder, you know. I just deleted that one line. I wonder if I snapped into an endpoint where they weren't. So.
That was the weirder.
You definitely have, like, if they're not,
Gotta be off, yeah.
yeah, something like, they're not centered over something, like, center line must not be projected totally. That one's not, so our center line projection, I think, is tilted. And it's throwing some stuff off, so it's different, trust for sure. That little segment there, really. So these are probably maybe off as well, like potentially, so good. That's. Leave it all. Get rid of it all.
It's not working. Something went wrong.
Projection, yeah, it's like, I can't trust this again. I think it's gonna be construction line work, this is this, just go down to here and stay zero, I like that. These are working on for sure, I just have my color set, yeah, so it should be, I should be getting the same. I think your circle is also not on center, so I gotta move this. Yeah, slightly, do everything up through. And we're gonna go by, so what, first, so yeah, you can tell right here, right, that I'm like, oh, my center didn't play. So I'm gonna shift select on center, looking for the center, there it is. That's one, I mean, that's one little, tiny little bit. And we wanna move it perfectly up and down like that. So that double bubble might go on this. I didn't move those, but I know it makes. Right now, my center should be on center. If I project down, and through. I don't. For a little bit of this, and yeah, it's like something. From, yeah.
Drawing it.
And see, that what I'm gonna do, what I could tell, like these rocks, just from center out, we're tip of that, now we reset the vibe, oh yeah, that's good. So now we got projected down. I think the next thing I do is when I get it, put it at set on. Unlock it, yeah. Good, now we have something to. Something to offset. These ones, I know the first offset is, 0.1875. The other one don't have quite enough. That's the majors, yeah, that's gonna be. Minor, or, 3073, 3073. You're using your calculator on your phone, that was your own, yeah. Oh, yeah, that's fun. It goes over here. Oh, you can always drag it. You can drag it over here. Grab it, drag it, yes. Get rid of the zero sometimes. 0.3072. Divided by 2. Well, offset this one, 15361, that's how no offset that. Now we're back. Putting in those lines, what are you trying? Let's see if we get this one now here. I'll just go. Should be able to tab over it. Oh, it's like this. Wow. Saw the number. It looks good, right? 80. Yay! Okay, but now what we gotta do is where this hits the major diameter, I'm just gonna draw straight across. Yep. Then I can trim all that out, trim all that out. And then you'll even trim this where that, this is where we come straight across actually. So this will get trimmed off and that'll get trimmed off. And then you'll come down here. And I think the thing we did was, yeah, 2 inches from here, right? Something like that, 2 across. Sure you have that drawn in. I hate those. One pitch, 0.65. One pitch like that. I still have my 45 angles on, so second. All right, just trim all this out. Yep. Okay. So you're back. Yay! I'm just doing the slot now. The last, yeah. So you got a little trimming to do. Hey, we saved it. Yeah. I kind of like that kind of stuff. I mean, to drive down and find like where did I go wrong? It's frustrating. It really is, you know. That is sometimes the case. I'm kind of this like hard-headed person. It's like, where did I go wrong? Yeah. But because and I think the reason is because in the drafting career, I'm used to kind of having a pretty big assemblies or pretty complicated parts, and I do feel like it's a lot more of like fine tuning it. Yeah, and especially working in a collaborative environment where maybe I'm working from someone else's model. I sometimes I don't have the time to say I would like to start this over because this is junk. And sometimes it's like, well, I got to fix what I can fix. And the time doesn't allow me to start over. And sometimes after you've been in trying to fix something for 8 hours, you're like, I wished I would have started over. So I mean, everything I say, there's also that it's even that sometimes it goes bad on me too, I guess. And I would probably, after a few hours of trying to fix something, I'd be like, nope, I'm not fixing this anymore. It's a waste. But if it is something that's going to cost me like days, I might be like, hey, design manager, are you okay if I fix this? Or what do you think I should do? Those are always good conversations to have. Hey, I know you wanted this and you thought we could get it done in 2 days. Well, guess what? When I get into the model, it looks like a total wreck. Do you want me to fix it or what do you want to do? And they'd be like, yeah, fix it. Or no, it'll be good. Just leave it. You let you let somebody make that decision sometimes.
Yeah. And then yeah, then they're like, well, who drew it first? It'd be like, I don't know. And then you look at, well, it was me actually. It was me like 2 years ago. I hate that thing. And it doesn't even take me that long. It might be I draw it like a few weeks ago and I come back, I'm like, "Ah, I hate this thing. What was I thinking?" But here we are. So I just got to draw the slot in mind though, right? So I think I hadn't done that yet. And then I think I'm almost done with, and that's what I'm doing right now is I'm drawing my slot width and depth. So I'm referring to this. I'm going to go at the large side of my range. So I just got to put in my 0.94 and a 0.103 slot depth here. So what I'm going to do, I'll get rid of my calculator. Oh no, I had my calculator up for a reason, I think. 0.94, that's the width, that's my slot width. So I'm going half of that is what? 0.047. I just cursored over there. This is the slot depth of 0.103 and back across 0.094 and then back up. And then I just need to do a little trim there, right? Just my visible line trim there. Yeah, cool. And then all I need to do is here I'll show you. So here how I kind of modify the top view is what I consider is the depth of slot here. So I'm doing some construction work. What I want to know is from here where it meets here. I'm going to project that up. And that should be where I can kind of see, as this tapers away, because what you have going on is this little machine head screw is like tapering down and away from me in this view. And so this I'm gonna see the slot kind of as it diminishes away from me, it's gonna be not out to the total edge of that circle, right? It's gonna as it tapers down the slot, I'm gonna see the edges of the slot kind of disappear. I don't know how to explain that otherwise, but what I want to know is this, and I could do both sides I could mirror this as well, but if I'm a completist here, maybe I could just do both sides. And I'm gonna project these up because essentially I'm looking down from the top, and I would see this, I would see where this slot kind of terminates, and so I think I'm gonna bring this up to here. I guess I'll just bring it up and across. I really only needed one side to do this, but I'll bring them both up. So this is kind of what as that thing diminished down away from me, it would be kind of this diameter. So what I end up doing here, I think, is maybe I'll do a visible one and then I'll have to trim it out a bunch. But essentially, it's going to look like this. Sorry, I'm looking for a circle, center circle here. Make sure I get my center here. There's good. Pull this out to here. So I think this is going to diminish to that point as yeah. So let me show you how this looks. I'm going to snap that. That's just the diameter of that projection coming up. If I turn this off for just a second, my projections, then I can kind of see what I have to trim. I'm not doing this, but it looks like that. Only as that diminishes, it ends up looking like that, right? It's like the surface has kind of been chopped out there because of the slot. And it goes down, it goes, I mean, that diameter is pretty critical because that's as far down as the slot goes. And the rest of the way there is no slot. So that's kind of why I see that like that. Does that make sense? Yeah. It's kind of cool. Oh, I know that's complicated, huh? It definitely has to be done with projection work. Once I had the slot depth established, I projected that over to that surface, that angled surface, and then I projected that up. And that ends up being kind of a radius of this arc here or this circle. And I projected both ways, and then what I did is I came up with a circle and I drew it on right here out to that point.
Would you want to have a hidden line there or briefly?
I think I'm just leaving. Yeah, and I think yeah, you could definitely, your hidden line work might be the major and minor diameter, or whatever. I think pretty standard is just to drop that so your view isn't too cluttered. Yeah, in a simple, yeah, because we definitely are drawing it as simplified as we can draw it. That's it though. That's one. Now we gotta do some work. Let's see. We'll get rid of that for a minute. I gotta go back to my worksheet and start pulling all the data for the next one, right? So I'll do that, and then maybe I'll try to do a couple of these and then call it part one of my day. You can see it's tedious, a little bit tedious, very tedious, but that's good. I kind of like this as a tedious exercise in being accurate, actually, more than it is what we're drawing. I like the tediousness of it because that is mechanical drafting. When you really drive down into some of the relationships of how things fit together, you kind of do stuff like this where you're getting pretty particular. So I like it for an exercise in that most anything. But here we go. So I'm going to fill out my B worksheet. It's already kind of given, so I've already started. I think I've preloaded the thread notes from the actual assignment, so I really don't have to even refer to it. I've got them right here. Major diameter is exactly what's given in the first thread note, so that's going to maintain a 1/2 inch. Whether you do decimals or not is fine with me either way. I mean, the major diameter was given as a fraction, but it doesn't matter to me how you designate that. Decimals probably is what I prefer, but I don't know why I did it in a fraction over there. That's all right. So the pitch on that, we just have to know we had to know our thread note relationship, how we figure out a pitch. This is how many threads per inch right here. And really threads per inch we consider from pitch to pitch of the thread, right? Threads per inch. So I take one, and if it helps you to write the little formula, that's fine. It's like 1 divided by 13 is how I would get my pitch. Because 13 threads per inch is how I read that. It's different than metric. Remember, metric bolts or hardware fasteners, they give us the pitch explicitly. We have like an M and then the major diameter, yes, in millimeters. And then the next one is actually its pitch, not its threads per millimeter or whatever. So in metric, and maybe metric is better again there because they're giving us the pitch rather than some weird like threads per inch, But yeah, so 1 divided by 13, let's do that math. 1 divided by 13. And then I'll just probably take this to like 4 decimal places. So 0.0769 is what I'll call that. 0.0769. What I have. Yeah. Uh, yeah. Minor diameter, I'm going to use this little formula here. It's that diameter, major diameter, minus that constant times 1 pitch. Well, maybe I need to know. Oh, and I already got my 1 pitch there, so I'm good. I should be able to put all this into my calculator, right? It's going to be my diameter. I'm just going to say 0.5 is my diameter. And I got to subtract it from a little bit of parenthesis math here, right? I got to do 1.0825. That's in my little formula here that I'd also find in Appendix B if I was looking there, but I've got it here for convenience more than anything, times the pitch, which is 0.0769, like that. And with a parenthesis at the end of that thing. Yes. That's my formula set up. If I hit enter on here, this should be my minor diameter here. So I'm going to populate this to 4 decimal places. So I'll call it 0.4168. Yeah. 0.4168 is what I'll call that. Head height. I'm going to have to go to the appendix on this one. I got to look and see what kind of fastener. It's a round head cap screw, So I got to go to my appendix for sure and look for round head cap screw. Pretty sure these are add-on ones. I mean, there might be some. I haven't. Yeah, there's this one. There's a slotted round head cap screw. I could probably use this. It actually is in Appendix B. Maybe I'll cross-check this one just for my own. But this is what we're drawing, right? Yeah. So this is a 1/2 inch. So we're actually in this row 3 here. Oh, it's got kind of a weird formula, right? 0.8875 times D minus this, which I can do this. Head height on this. is it? 0.875 times D minus, yeah, 0.875, yeah. Times the major diameter, 0.5. Minus this little correction I call, let's see, 0.83. So I think our head height, according to this chart, is 3545. So I'll put that in there, and I might just cross-check that with 3545.3545 is what I think is the head height. If you used a different, there, I'm sure there's a different one that I've added on the bottom or in the end of this appendix. Maybe did I do the round head ones? I thought so. Yeah, these round head, I guess, machine screws. I don't know. Maybe they explicitly give us some stuff, so it's kind of handy. So and this is I think where I'm going to get the information for the slots here. We have what is their head height on a nominal size? Oh, it's the very last one. Head height we say is 0.355. 355. Yeah, technically I could round that up to 355. So really that chart and the other chart really are ones to four decimal. Well, when I do the math, it takes me to four decimal places. The other one's just kind of held to three. So technically it's the same. Same. I think that other chart had the head diameter, so maybe I'll just stay on this chart though and look at what the head diameter is for a 1/2 inch. Has a range 0.813 to point. So this one has a range type of diameter. And I guess the head height too. So there is a range there. And it's explicitly given, so I could just pull that dimension. I think on this other one, not that you have to check back and forth between each of these. I just kind of do this for my own sakes to see if I have conflicting data in some ways, but it did give me the head diameter of ability here to figure out for my 1/2 inch row 3 here. It's going to be 2 times the diameter minus this. So I'll see what this turns out to be. 2 times the diameter, subtract this correction, 0.1875, 81, 8125. I think that other chart said 813, so I think it is really close. This one wouldn't give me the range though. This is just give me a single number. So I'll just do this one. 81. It would be the high side of the range from that other chart. 0.8125 is what I'll say is the head diameter. 0.8125. 81. Wait. Did I say that? Is that the right? Hold on. 8125. Yeah. I'm going to do fully threaded here as well. And then I just need to know the slot width, which is not given on that appendix. It's on that other one. So technically I could stay on this one for all of my dimensions and probably be just fine. This little round head machine screw chart that looks like it's from the 1950s. I can't remember where it came out of, but probably did. These are old style of machine head screws. And these technically aren't, I mean, these are wood screws, which could be a coarser type actual thread cut too. So this could technically be, it's kind of machine. Oh, it's both, right? Huh? Yeah, that's right. That's right. Yeah, you're right. It's just a couple of wood screws thrown in here. Yeah, you're right. Just to see if you're paying attention to this chart. It's got a few wood screws in there. Otherwise, it's machine screws. Yeah, and they would be a totally different type of thread for sure. Yeah, wood screws meant to grab, bite, and do its own kind of drilling and tapping in one, and our machine screws don't do that themselves. We gotta machine them so that we have a nice fit. They don't cut their own way. 1/2 inch. So yeah, I'll use these slot depths. So I think I'll just go to the high side of the range here, and for no other reason, just because, just it's an easy number to see. So I've got the width of slot as 0.106. And I've got the depth of slot as 0.211. I'll just use those two, the max width, the max depth. 0.106, 0.211. So I think it was 0.106, 0.211. I'll double check that, but I think so. slot width of slot. I just want to double check my sheet that I've got it right. Slot width, slot depth. Yes, I do. Okay. Easy to get that wrong. Now I've got all the data I need to go draw this thing, so I think I will. Let's draw this thing. Pull this up on my other screen. Start. Well, I'll pretty much lay it out the same way. I think I'll start with the top view again. All of my lines look like I've inaccurately placed them. At least this next set, I got to move this thing. I can see that I've got a misalignment here. And from anywhere on it, maybe it's midpoint is what I'm going to put right here. Yeah, when you're starting to project from it, if it's not lined up right, it does cause problems. Head diameter is what I need to know here. So I have that in my chart, right? My head diameter is 8125. So I'm going to draw a circle on center here. Oh, I'm drawn by radius. That's actually diameter. That's okay. I'll jump out to my calculator here. What I'm missing is I just need to know the radius of that. If it's a 0.8125 diameter, what's that divided by 2? 40625. So I'm drawn by radius here. If you drew by diameter, you're probably already ahead of me here. But I'm drawn by radius. 0.40625. Yeah. There's my head. I can put the slot in here too while I'm up here. The slot width I have as 106.106. I'm just going to offset half of that. So the whole slot width is 0.106. I'm going to divide that by 2, and that's my offset. Of course, I have nothing going into my calculator, so I'll try that again. Clear it. 0.106 divided by 2. 0.053. I'm going to offset this thing. 0.053. And that's my slot width, huh? So I'll trace over that with my. And this one we may come back and like fine tune that too when we're done. But that's definitely how that's going to look initially. Allow me to project down some data. I think once you do one of these, they get a little bit faster, maybe. They'll do the same thing. That kind of worked well for me to just draw a center line and use it as my offset line. I got to go back and fix this up. I can't remember if I came back here and fixed this though. I know the top is actually extended correct, but this is 0.25. While I'm thinking about that, I'll clean that up. And I will put a center. I think I put a center mark on these when I finished. Yeah. Let me see. Yeah, I ended up putting a center mark on those. I didn't pull them all together, but you could have done that with just a single line through all of them, or I think I've done them individual center marks. I'll probably do that again, but we can come back and do all those heads once we get there though. So let's see. I've been fixing this one. And then offset these. So I just need to know my major and minor diameters to offset them for the visible and hidden lines down below. So my major diameter is 1/2 inch. That's going to be pretty easy. This is going to be a 1/4 inch offset for the major diameter, there to there. Of course, we want that to be on this layer. And then the minor diameter, I may have to do some calculating because it's 0.4. The minor diameter is 0.4168, so it's an odd 0.4168 divided by 2. So I'm going to offset for the minor diameter 0.2084. Yeah, let's do that. Offset 0.2084. Those should be hidden lines for minor diameter. Nice. I can put in the length and kind of trim the end of it too while I'm in here. So I think the length was given 2¼ inch long. So I'll draw that into as visible object line. So it's So that is from here. So that's the other thing to note is that this one is measured from the head, from the underside of the head down, and that is really a common. And not, I don't know if it's gonna. I don't know where it says that in our.
It shows it on the chart for the distance arrow.
It does, and they were given here 2.25 inches long. Yeah, but in your reading, you might find like and that might be you just have to be careful with your fasteners, like where when you're trying to pick a length of stuff, just be aware. Like if you're ordering stuff online, I like the schematics that we can pull up, and when we go look at these, I'll show you they're pretty descriptive on where they're pulling their lengths from, and so it's really helpful to have like an online resource. Um, um,
On B3.
it shows that it's oh yeah. Is not it doesn't include the head length, right? Yeah, exactly right. So if you, yeah, I think here and all of them, and that's good that shows because the flathead machine screws shows that like the length is considered everything, including the head. The length is considered not the head there. Yeah, that is good. So it does show those differences. And those are common. I mean that is I have it memorized and thinking that, oh yeah, from a hex head bolt, it's that way too. That's how I remember mine from mostly is that major, like this bolt is what kind of sets that standard for me. And this is a real common bolt used in a lot of mechanical parts. And I've just always memorized, oh, it's from the underside of the head is the actual length of the bolt call out. So, and then it's pretty common for most, like flathead machine screws kind of break that rule, but all the other ones are kind of from that. I don't, we have that Philister head one and we have that oval head one. Those are kind of oddball ones. So let me go down to where those are shown and see if they show that set like this one here. Yep. So for the Philister style, it's definitely going to be from the bottom of head down as length. And I'm just kind of curious on this one if they even show. I can't say that these ones this one could confuse me. I'd probably need to go to even a different for this type of fastener if I really need to be particular. I don't know where off the top of my head, I don't know where they pull the length for these, and they don't show it on these clearly. So this one I'll have to be careful with a little bit. And maybe I'll pull up Mastercar. But that's the only one that's kind of an odd one out. And if I went to my old drawing, I could probably measure where I did it. But it's definitely the one I don't know if I pulled it from here down or yeah, I'm not sure. I'll look it up. That's definitely one I'm probably gonna look up online. And that might be the first one I pull up on McMaster-Carr or something, just to see if it gives us that in more detail. But I'm not worried about that yet. I'm just worried about the one I'm on, this one. So we gotta do the round head here in the front view. So what I need to know is that diameter, and then so let's go back here. This one's here. Yeah, the last it depends on which one. Like these ones were offset by um 0.40625 because that's half of the major diameter. So that's my 0.40625 here. And then I offset the minor diameter by point. There's my minor. Is that right? Is that what I did? I don't know what I did. That doesn't sound right. Does that sound right? No, it's point. Oh, I offset this one as point. It's a half inch. Well, sorry. So this one is out point. Sorry, it's 0.25. The first for the major. My heck, it's a lot of dimensions to keep track of. 0.25 is that one because this is a half inch diameter major. The minor diameter is this one, 0.4168, according to my sheet, right? 0.4168 is minor diameter. Half of that is what's on my calculator here, 4168. So this one is offset 0.2084. It's confusing, huh? I don't on my calculator I don't show the major one because it was an easy one. It's just half inch is 0.25. So 0.25 offset, 0.2084 offset. Got it. The length I'm going to pull down from here now. That's the whole reason why I was going over there. Is this is 2.25, right? 2.25 is the length of this one. I forgot how long these take actually. I do remember doing this for probably a week and a half here now that I think about it. Yeah, by the time I go through them. I'm going to offset that by a pitch. And so we have that in our chart. I hope we have that pitch right here. Yeah, so they're definitely not the same. Everyone will be different based off how coarse or fine it is and its diameters. So here's the pitch, 0.0769. So I'm going to offset that thing by a pitch. Offset. 0.0769, enter. Let's offset that thing. Perfect. Make sure I'm going to draw by 45 still. Yeah, it seems like I've been able to keep that almost time. So I'm just going to draw this down at a 45.
How do you do
It is the pitch
that?
right here. Oh, no, no. Oh, the whole thing, yeah, is 2.25. It's on the chart, right? 2.25.
Oh,
Length. It was really given. I mean, I'm not, it's actually given in the thread note for the whole thing right here by its length, 2.25. So I didn't have to, yeah, it was actually a given. I think all of them I've populated what was given in the upper problem, I think. Yeah. Looks like it. Heck yeah. What do we got to do now? Just got to do some trim, huh? Trim this stuff out. Looks good for the finish there. This thing can be tucked in while I'm down here. Then I just need the rounded head on that. So this is the diameter of that. So I think I can just draw by a 2-point circle maybe here. The diameter of that head, I have it up though, is this head diameter 8125. So I'll keep that up in case it comes in handy. But really this thread diameter, I think I could just pull this circle here, yeah. That's the head diameter. Just need to trim it out. This is all gone. And I don't need this part of the circle. And I could have turned these off to maybe make it trim easy. This will be all right. Less than that?
Head height.
I gotta go head height. You're right about that. And then I gotta do an arc. Yeah, 3 points maybe. I mean, I could do a 3-point circle. I think you're right. This is gonna be too tall, right? I gotta figure in the head height. I agree. If we jump to that conclusion, I think we're gonna be wrong. So I want to calculate, and a head height should be on my chart. Yeah, it is. Head height is there. Head height. I have to be. Yeah, so maybe I'll offset my line there, 3.545 first, so I know that overall head height. So I'm gonna offset. I haven't drawn this line, but I will have this visible line across here. So I can at least put this line in. Then I have something to offset maybe. So I'm gonna offset at 3.545, 3.545. Yeah, so 0.3545. Yes. Thank you guys for keeping me in line. That's as high as it can be. So this shows that if I pull the diameter in that front view, I'd actually be kind of exceeding the actual head height here. So this is going to be a deleter here. Get rid of that thing. It was the right idea. Really, it could be an arc. I could actually do this as an arc too. So I don't know. Let me try a 3-point circle. Would that allow me to go here, here, here? Yeah, a 3-point circle would be great. And that's not a common one you use, but here's a situation where a 3-point circle is going to get you your head profile. You could do an arc too with an arc center end or start center end. This is like a start. Then it wants to know the center. This is probably not going to pull the right way though, without doing like a reverse way. So it's not what I want. The other thing I want is this is a construction line though. Okay. I like my 3-point. I think I like my 3-point circle. Tangent, tangent, radius. Tangent, tangent, tangent. I don't know. Tangent, tangent, tangent might work. I like experimenting with this kind of stuff. Bam, that would work too, right? That's cool. Based off your geometry, you could use several different. I like that because it's different. Some different circle commands we don't use commonly, maybe. Yeah, I like that. So I'll leave it. Trim it out now. That's the actual head height. Essentially, the center of the circle is a little bit lower. Yes, it is that diameter, although that didn't look too super good there. That's kind of weird looking. I don't like that one as well. That's weird. I went tangent, tangent, and it dropped it in. I want it to stay that profile, so I don't like this after all. Here we go again. Didn't know that until I zoomed in. I think I am going to like the 3-point better. So it's going to be point to point to point. Yeah, that's better. It actually drops the center of my circle down here is where that's really based off of. But this I like better. I'm gonna do that. So maybe there is a right way and a wrong way. Didn't know until I zoomed in a little bit that I was not actually hitting that tangent.
But now if we take the slot out of it, it'll be shorter.
Oh no. I know it will be. That's all right.
Which I
Technically, the
think-
theoretical height is there, though. We'll call it yeah, we're gonna chop out the actual apex of that height, but theoretically it'll still be there if it could continue. Yeah, I'm gonna go with that as my reason. Because what I need is the slot. Now I need to do the little slot here, huh? Yeah. The slot width and height on my chart, I have it as a slot width is 106. I don't know what half of that is. Maybe I'll figure that real quick. 0.106. This is gonna have, oh, I can't do that. Oh, it doesn't like me just to delete that. My calculator's kind of, it confuses me sometimes. 0.53053. This is just me saying I'm gonna cursor over here. 0.053. Then I'm gonna come down. Yeah, that's oh yeah, I see that. That's a pretty good point. I'm gonna just come down from its theoretical top, and I'm gonna come down from there. I mean, it's a real small detail, and maybe I'm drawing it slightly wrong, but I think we'll go with it. It's already pretty complicated for sure. That's how far down that goes, right? And then it goes over the actual whole width, which is 0.106, and then back up. So, and then I'll trim all that out. I think I'll just leave that as based off its theoretical height. Yeah, let's say that. We'll trim out here. Good. Yeah, I think I'm going to leave it like that. Well, we only have a lot more to go, right? Holy
But
cow.
what's to fix the slot?